Welcome to today's video on Spearman's rank correlation coefficient. In one of our previous videos, we have already seen about correlation analysis and the calculation of Carl Pearson's correlation coefficient both manually as well as using Excel and data analysis pack. Today we'll see about Spearman's rank correlation coefficient, which is a measure which is useful for us when we have to study correlation for data that can be ranked. We have seen examples of ordinal data like severity of a disease, pain scale, etc. This correlation coefficient can also be used for continuous data if the data is not normally distributed or when we have outliers. Spearman's rank correlation coefficient can be used in the place of Carl Pearson's coefficient. The formula is rho, which is the Spearman's rank correlation coefficient given by 1 minus 6 sigma d square by n into n square minus 1. So n into n square minus 1 can be written as n cubed minus n. We need only two terms. D is the difference between the ranks and n is the number of items or the sample size. So in case we have a problem where we have the ranks of the variables itself given, then it is very easy for us to calculate. So what we have to do is, we have to find out the difference between the ranks. So is equal to, so we have a rank X starting from B18. So we can put it as B18 minus C18. So we have got the difference. So we can use the fill handle and we can drag and drop till we need the differences in ranks. For D square, we need the square to D18 power 2. So now we have the square. We can do the same thing. We can use the fill handle and we can apply the same formula to these cells and we get the squares of all the D. Now we need the sum of this because the formula is 6 sigma D square. So we can find out the sum using the auto sum function. So this is 36 and we need the total count. How many observations? So we can put it as is equal to count. So what are the cells that have to be counted? This many cells. So the total count is 10. So we have got both the terms that are necessary for us. Now we have to substitute it in the formula to get the answer. So we can put it as is equal to 1 minus, and we can start with a bracket because the whole term has to be subtracted from 1. Then for the numerator calculation, 6 sigma d square, which is 6 into 36, which we divided by, as I already told you, we have to open another brackets for the denominator and we can put it as n cubed minus n directly. So it is 10 cubed minus 10 and close the brackets for the denominator and close the brackets for the entire term so that the entire term gets subtracted from 1 and we get our answer, which is 0.78. And just like we saw in Carl Pearson's correlation coefficient, you can have range from -1 to +1. If we have a negative sign, it indicates negative correlation. If we have a positive sign, it indicates a positive correlation. and a value close to 1 indicates a good correlation. 0 means there is no correlation. This is just like Carl Pearson's correlation coefficient. Now we'll move to another problem where we have to find out the ranks. So here we have been given a set of 5 students, their ranks in 2 subjects, and we have to see whether there is a correlation between the marks that they have scored in the 2 subjects. So we can rank it and then we can find out the correlation coefficient. As we have seen, we can also use it for continuous data whenever we have any outliers or when we have a data which is not normally distributed. So now for finding out the rank, as we have already seen, also insert many of the functions that we have seen in the insert function option. So is equal to, so when I start typing rank, I have rank average and rank EQ. I have to choose the rank average because if I have values where the ranks are same for 2 values, then it will give the average. So it is better to choose a rank average. Now I have to give for which number I want the rank first. So here I have to give it as the cell which I need is B39, and then I have to give what are the cells that have to be referred. When I'm doing this, when I'm referring to the cell, I have to use absolute references so that it considers all the, for all the ranks it considers all the cells. So how I have to put it as, whenever we want an absolute reference to a cell, we have to put a dollar symbol before it. So a dollar symbol, then B, again a dollar symbol, and then 39, which means I am giving an absolute reference to this particular cell, and colon till how much it has to come till B43. Again I have to give a dollar symbol, then B, again a dollar symbol, and then 43. Now I have to indicate whether I want the ranks to be in a descending order or in an ascending order. Now I want it to be a descending order. So the highest mark I will give rank 1. And so I am going to put it as 0 and then close the brackets, enter. So now we have got the rank as 2. So now the same thing we can apply the formula to all and we have the ranks for all this. Similarly for the next one is equal to, again start as rank, choose rank average, then I need the thing for C39. So C39, then again I have to give absolute reference to the cells that have to be considered. So dollar C, again dollar 39, and it has to consider till C43. So dollar C dollar 43. This is the range that has to be considered. Then I need it in the descending order. So I have to put it as 0, close the brackets. So I have got the rank as 1 for this. Now I have to just apply the same to all. So I have got all the ranks, and once I have the ranks for both, I can find out the difference and I can do it just like we did for the previous problem. You can find out D, you can find out D square, and you can substitute and you can find out the answer using the formula 1 minus 6 sigma d square by n into n square minus 1, just like we did for this problem. Thank you.